When we are doing the product between two vectors, we can have, for instance, the scalar or dot product, and we have vector A, for instance, it has its components, and we can have also the product B or the vector B, which has its own components as well. And the dot product is called the dot product because we use the symbol A dot B in order to express this is a dot product. And the answer here is going to be a scalar. This is going to be the result. That's the reason why it's a scalar product between two vectors. And by definition, for instance, A dot B is going to be equal to the magnitude of vector A times the magnitude of vector B times the cosine of the angle which is between vector A and vector B, such that if we have, for instance, vector B running in this direction and vector A running in this direction, this angle is going to be the shortest angle between both of them, and the scalar product A dot B, once again, is going to be magnitude of A times magnitude of B times the cosine of the angle between both of them. This means that if we want to find the angle between both of them, and this is one of the applications, the angle between two vectors is found as the inverse cosine between the dot product A dot B over the magnitude of A over the magnitude of B, and this is solving from this equation. If we want to do the product between unit vectors, for instance, we have to understand that if we have vector I as a dot product of vector I by itself, then the magnitude is going to be, for instance, 1, because this is a unit vector, times the magnitude of the second vector, which is 1, which is a unit vector, and the cosine of the angle of both of them, which is 0 because they are running parallel, and parallel vectors cosine of 0 is going to be 1, which means this is going to be 1. The same situation happens with, for instance, J dot J, and of course K dot K, since both of them are parallel vectors. If I, for instance, do I dot J, then I have to understand that this is the magnitude 1 times the magnitude 1 times the cosine, and the angle between these two vectors, since they are totally perpendicular, is 90, and this is 0, which means I dot J is 0, and the same happens, for instance, if we have J dot I, or if we have, for instance, J dot K, or K dot J, or for instance I dot K or K dot I, and this is equal to 0. And if we multiply these two vectors, then I want you to understand that I have to multiply the first term times the 3 of the terms in the second equation, and then, for instance, the second term of the first vector times the 3 terms of the 3 vectors of the second vector times the third term of the vector times the other 3 terms, right? Doing the first, the red one, will actually state or will actually generate ax bx, which are the product of the components, times I dot I, and for instance plus ax by times I dot j, but I dot j we know is 0, so we can cancel this, and ax bz, the components, times I dot k, but I dot k is 0, so we can cancel this, and we only get this number in the first with the first term. And the same will happen, for instance, if we have ayj times bxi. Those will cancel, and we will remain only with ay times by j dot j, and for instance az bz times k dot k, and all of these I times I, j times j, and k times k will go to 1, which will mean that at the very end a dot b is going to be, for instance, ax bx plus ay by plus az bz, and this is, for instance, just a number. This is a scalar.